YouTube channel. Naren here. This is the second video related with section 5.1 angles and their measure. Today we will continue discussing from where we left off. We discussed last time degree measure of angles, and today we will discuss radian measure of angles. This radian measure of angles is useful while studying trigonometry and calculus. Now we will start from some definitions. First, we will discuss the definition of central angle. So the definition: an angle with the vertex at the center of a circle. At the center of a circle is called a central angle. It's called a central angle. So this is a definition of central angle, figuratively explaining any angle subtended at the center of the circle. So this theta is central angle here. Next we have another definition: an angle theta, or an angle that intercepts an arc on the circle with length equal to the radius of the circle. Radius of the circle has a measure of 1 radian. This is definition of 1 radian. Is denoted by 1 radian or 1 radian or simply 1. So these are the notations. Another definition: the radian measure of a central angle, theta, subtended by an arc of length s on a circle of radius r. Is given by theta equals to s over r. So what does this mean? So figuratively explaining, this means if we have a circle with radius r and arc length s, the angle subtended by this arc length is given by this relation, and whenever this arc length is equal to, so this is equal to, they are equal, it's 1, right? The theta is 1. So this measure, whenever this arc length and this radius are equal, the angle measured at this position or at this condition is called 1 radian. So this is what the definition, the above 3 points are telling us. Now question, or the point, remarks, I would say remarks: this formula is only valid when s and r have same units. And number 2, as a question, the radian or just the remark, the radian measure carries no units. So it carries no units. What was the reason? The reason is that they are measured in same, first of all, this is a ratio and they are measured in same system, either centimeter centimeter or kilometer kilometer, such type of thing. Since we are um, dealing in circle, if you notice, so if you have a circle, if you notice, say you started at this point, when you revolve one complete rotation, it means you are obtaining one revolution, you are making an angle of 2 pi. So one revolution equals 2 pi radians, which is approximately 6.28 radians, and which is equals to, in degrees it is 360 degrees. So this is very important point to notice. So what does this imply? This implies that when we go, number one, when we are given any angle in degrees, and if we wish to go in radians, what we do is we multiply by pi over 180 degrees, and if we are given any angles in radians, and if we wish to go in to degree units, we multiply it by 1 over 80 degrees to over pi. Let's do a couple of examples. So couple of examples related with point A. So say I'm given some angle in 1 degrees unit, 120 degrees. How to convert it in radians? So I multiply it by 1 pi by 180 degrees. So if you look at carefully, 0 and 0, you can, and both the numbers are multiple of 6, so 2 pi over 3. So this is the corresponding value in radians. Similarly, number 2, say you are given any angle in radians and you wish to go in degrees. So how do you go in degrees? You multiply by 180 over pi. So basically you cancel this thing, put it in the lowest term, so pi goes away, and 18 is multiple of 9, so 20 into 8, which is 20 into 8, which is 160 degrees. So this is how we convert degrees to radians and radians to degrees. Next one is the definition again, and the definition is coterminal angles. Two angles are said to be in coterminal are said to be coterminal angles, coterminal angles if if uh, if both are in standard position, and standard position with same initial side and same terminal side. uh, so for example, okay, before the example, let's make one important point here. Two angles in standard position are coterminal if their measure differ by a multiple of 360 degrees or 2 pi radians. So if you are dealing in degrees, their measure differ by multiple of 360, or if you are in radians, it differ by multiple of 2 pi radians. So for example, now let's take an example. Let's say theta 1 equals to 50 degrees and theta 2 equals 410 degrees. So if we look these two angles figuratively, so theta 1 is, so first of all they have to be, we have to draw them in standard position. So this has to be the initial side, so this has to be initial side, and for theta 1 the terminal side is, say, this one. So this is terminal side for theta 1, so this is theta 1. Now theta 2, to get theta 2, so look at here, if I add, so theta 2, I can obtain theta 2 which is 410 degrees, but this can be obtained by adding 360 degrees. So what does this mean? This means that I have to start my angle from standard position and revolve around and get back to the same position at where it was the 50 degrees, where it was 50 degrees. So this angle is theta 2 now. This is theta 2. So the difference, if you take the difference is 360 degrees. So difference is 360 degrees, which is a multiple of 360. Hence they are coterminal angle. So let's do few problems related with this. So problem, find a positive angle. So we have to find a positive angle and a negative angle, that is coterminal to given angle, that is coterminal to negative angle, coterminal to given angle. So first question is, given angle is 110 degrees. So how to solve this problem? So positive angle, since the difference should be 360 degree, one angle coterminal to this can be obtained by adding 360, which is basically 470 degree, and another can be obtained by subtracting 360 degrees, which is negative 250 degrees. So these two are also coterminal to each other. So similarly, if we are given uh, angles in radians, how do we find it? So how do we find a positive angle and a negative angle? So in this case, we add either 2 pi or subtract 2 pi. So positive angle, to get positive, we will add here because it's already negative. So this will be, if we subtract it, this is 2 pi minus pi over 4, and if we subtract it, we can get 7 pi over 4. And another angle can be obtained by subtracting 2 pi. So subtracting 2 pi is going to give us minus 8 pi over 4, which is negative 9 pi over 4. So this is how we find the coterminal angle, positive coterminal and negative coterminal angle. But say I only want to find a coterminal angle. Given some angle, I want to find a coterminal angle that lies between 0 and 60. So find an angle between 0 degree and 360 degrees that is coterminal to the given angle. Number A is 910 degrees. So how to find this? So basically, I want to find a coterminal angle that coterminal to this angle, 910 degrees, that lies between 0 and 360. So first of all, I will have to figure out how many 360s are inside 910. So basically I will just divide it by 360. So I will get some, definitely I will get 2 point something, 2 point some value. So at least 360 degrees, two complete rotations, two complete revolutions are there. So how can I find it? I can basically do simple math, 910 degrees, and I will subtract 2 times this 360. So this will provide me whatever I get. I will get a value that lies between 0 and 360, so which is 190 degrees. Turns out to be 190 degrees. Similarly, say I have negative 80 degrees. Now how do I find how many 360 degrees are here? Since this is already a negative angle, I will add 360 degrees. How many 360 degrees are here? There are 0 360 degrees, right? There are, but you want to find a positive angle that lies between, before completing one revolution. In this case you already have a coterminal angle, so you don't need to divide here in this case because it's already between 0 and 360. So in this case you just add. If the given number is between, if the given number is positive, you angle itself is a coterminal angle. If given angle is negative, if you want to find a positive angle, then in this case you just add 360 degree, and that will provide you, because you are not completing any rotation here, and no revolutions are completed here, so which is 280 degrees. So this is how we deal. Say I change the instruction by writing here 0 and 2 pi. Okay, let's find coterminal angle that lies between 0 and 2 pi, so which I will say number C. So 17 pi over 6. So basically we are finding how many complete rotations are there. So if you look at here, their complete rotations, revolution means how many 2 pi's are inside there. So if you divide it by 2 pi, or you don't have to divide it by, just if you use this, uh, um, convert this into corresponding decimal, it is less than 3 pi, right? So less than 3 pi, so which means at least one complete rotation is there, and another, while taking the another revolution, you have already found the coterminal angle. So if we subtract 2 pi, that will be sufficient. So let's subtract 2 pi from the given. So in this case we just subtract 2 pi to get the coterminal angle, which is 17 pi minus 12 pi over 6, 5 pi over 6. Now you can see that 5 over 6 is less than 2. So in the number D, negative 35 pi over 2. Again, this is also less than 3 pi, okay, because 12 times 3 is 36. So this is also, so we will, but since this number is negative itself, I will add 2 pi. I will add 2 pi. So let's add. So I'm adding 2 pi. Negative 35 pi over 12 plus 2 pi, which will give me 24 pi minus 35 pi over 12, which gives me negative 11 pi by 12. But this is a negative number. Do you want this to be negative number? No. So because we want positive number, we again can add 2 pi, and find this number, which is 24 pi minus 11 pi over 12, so which is 13 pi over 12, now which lies between 0 and 2 pi. Another thing what we could have done here is we could have uh, multiply here by 2 pi, because this is negative, so this is negative 2 point maybe 9 something pi. So if you are going from negative 2 pi, if you want to find some number here in 2 pi, so here is 2 pi, right? So when you move 2 pi here 1, so you will have to move 2 pi here, this shows 2 pi. So you have to use this some common sense also sometime to reduce your to save your time, otherwise this is how we can solve it. Now in my next problem we will we will compute arc length of a sector of a circle. So first of all, what is the sector of circle? So definition, uh, given a circle and two rays, say this is radius r up to here and this is arc length s. How to compute arc length? So we know the relation from our previous discussion that theta is given by s over r. So this will give me s equals to r times theta. How to calculate these arc lengths? Next, so let's do a problem related with this. Say you are given theta equals to pi over 12 and r equals to 14. So how to calculate arc length in this case? So s equals to r theta, simple formula. So remember this, in this formula this is only valid when theta is given in radians. If theta is not in radians, we are supposed to convert theta in radians. So r theta, and this is simple, just plug the values and get 7 pi over 6. You can plug the value of pi to get the exact answer. There is another problem here, say number B, theta equals 20 degrees and r equals to 2 feet. So how do we find s? S equals to r times theta, but since theta is in degrees, we are supposed to first convert this into radians. So how do we convert this into radians? Pi over 180 degree. So this will give you corresponding radian value and r. So this whole thing is r in radians and 2. So whatever we get is, after simplification, 2 pi over 9 feet. That's our answer. Do not forget to put units always. Using the importance. Now application of this formula. Let's do an application problem. Application of this formula is very interesting. Let me put this problem here. Some city x is located at this location, 24.1 degree north and 81 degree west, whereas city y is located at this location, 41 degree north and 81.7 degree west. Now we can find, using these locations we can find, these are latitudes and longitudes. Longitudes are, if you look at here, this is 81.8. Longitudes are degrees. All these numbers are in degrees. Longitudes are nearly same. These are the longitudes. So the different things are the latitudes. So we can use difference in latitude to find the distance between these two cities, city x and city y. So how to find? For this we will require radius of earth. So radius of earth is given by into units. In miles it is 3,960 miles, whereas in kilometers it is 6,400 kilometers. 6,400 kilometers. Now how to find? First of all, we require to find the angle between theta, angle between x and y, the cities x and y, which is difference between these two angles, 41.5 minus 24.1, which gives me 17.4 degrees. Now since we will be using this formula s equals to r theta, so we will convert this into radians, which is I need to converted this into radians, pi over 180 degree. So whatever number this is, I will directly plug the value. So distance between cities, city x and city y, distance between city x and y is given by s equals to r theta. So what is r? R is given by the radius. If I use kilometer, we will have to use our final answer is in kilometers. If we use miles, the final answer is in miles. So what is theta? Theta is 17.4 degree times pi by 180 degree. If we use so whatever value we get, so that will be our distance. So let's since I have already the provided value in miles, um, let me use miles over here, which is, then I have to change it to, so which is 1188 miles approximately. uh, so this is how we find distance between these two cities. Or kilometers, if we want to change it into kilometers, put the while using calculator, put this value, change it to 6400. So this is how we can use these formulas in our real world. I will make another video on this section, which will be more interesting, because I'm gonna discuss linear speed, angular speed, and many more things, which will be also helpful to physics students. Until then, thank you so much for watching. Do not forget to subscribe my YouTube channel. Naren here, Naren underscore here. Thank you so